In this video, we're going to continue on with our base E, exponential, and logarithmic functions, and we're going to talk about base E logarithms. So the logarithmic function that is base E is called the natural logarithmic function, or natural log function. So log base E of x is the same as ln of x, where ln is our log base E, and we call it the natural log, or natural logarithm. So remember that our logarithm functions, the domain and the range are opposite. So the domain in this case is all x is greater than 0, so from 0 to positive infinity. And the range, however, extends from negative infinity to positive infinity. And you can see a graph of the logarithmic function, natural logarithmic function, on page 955 in the text. So our properties of logs still are the same, and when we apply them in these situations. So natural log of e to the fifth. Think of this as log base e of e to the fifth. Well, what happens? The log base e and e cancel, so we're left with just 5. So natural log of the cube root of e, remember that's the natural log of e to the 1/3. So cube root is 1/3 power. So again, natural log of e cancels, and we're left with just 1/3. Natural log of e, this is an interesting one, so remember that would be like log base b of b. This is just 1. And then the natural log of 1 over e to the 7th, that's the natural log of e to the -7, so what we're left with in this case is just -7. The same property of logarithms that we talked about with regular logs applies. And then of course we can actually apply this sometimes in a word problem setting, where it says here that this function models the percentage of the population of endangered Alcorn's pocket gophers remaining X years after 1965. So what we want to know is, what is the percentage of gophers remaining in 1991? So what are we going to plug in for X? Well, how many years after 1965 is 1991? Well, let's think from 1965 to 1970, that's 5 years. And then 70 to 91 is 21 years, so 21 and 5, so that's 26 years is what we are going to use. So what we're going to do is look for f of 26, which is -6.84 times the natural log of 26. Now we're going to do that in our calculator. Okay, and we're going to figure out what this is. So you can do natural log on your calculator. It does that for you, no problem. And make sure you follow the order of operations, because we're taking the natural log of 26, but we don't add the 47 to it first. So what we get is 24.71. And this is a percentage, so this is how many percent of the original population are remaining. So they're going down because they're endangered, so there's not many left, less than 1/4 of them left by 1991. And then it says use this function to find the percentage left in 2007. So again, in 2007, so from 65 to 2000, let's see, that's going to be 35, plus another 7, that's going to take us to 42 years. So f of 42 is, again, we're just going to use this function. I'm guessing there's not going to be many left, but we'll see here. Okay, so the way I do it is I take the natural log of 42, and then I multiply by the -6.84. Let me try that again because I typed it wrong. And then I add to that 47. And it looks like what we're ending up with is 21.43% remaining. Okay? So that's how we use the natural logarithms. That's all for this lesson. We'll see you in the next video.